Hello, everyone. My name is Christian, and my partner is Paishan. Our project is called Comparative Queue Simulation of a Coffee Shop using Excel, Cloud, and R. For this project, we analyzed a coffee shop queuing system to see how the number of baristas affects customer waiting time, queue size, and service efficiency. We compared a one barista system against a two barista system using three different simulation approaches: Excel, Cloud, and R. The main purpose was to see whether adding a second barista meaningfully improves customer flow and reduces delays. The objective of this project was to evaluate how service capacity affects queue performance in a coffee shop. The system follows a simple process. Customers arrive, wait in a line if the barista is busy, receive service, and then exit the system. Even though this system seems simple, randomness makes the system harder to predict. Customers do not arrive at a perfectly even time, and service times can vary dependent on the order. Because of this, simulation is useful. It allows us to test different staffing scenarios without changing a real business operation. For our analysis, we focus on several performance measures: average waiting time, maximum waiting time, average time in the system, queue size, and resource utilization. These measures helped us compare whether one barista or two baristas perform better. For the model setup, all three simulations follow the same basic queuing structure: customer arrival, queue, barista service, and departure. The main comparison was between one barista and two baristas. In the one barista scenario, customers had to wait whenever the single barista was busy. In the two barista scenario, customers could be served by whichever barista became available first. Each tool handled the simulation differently. Excel was used to manually calculate queuing values step by step. Clouds was used to create a visual process simulation over a simulated workday. R was used to build a code based simulation that could be repeated and adjusted easily. Using three methods allowed us to compare not only the results, but also the strengths and limitation of each simulation tool. The Excel simulation was a spreadsheet based model. It allowed us to clearly show the queuing calculations using formulas. In Excel, we compared k equals 1, which represented one barista, and k equals 2, which represented two baristas. For the one barista scenario, the average time in the system was 0.3064 units per minute, and the average waiting time in the queue was 0.2707 units per minute. The average number of customers in the system was 7.6591 units per minute, and the average number waiting in the queue was 6.7670 units per minute. When we changed the model to two baristas, the results improved significantly. The average time in the system decreased to 0.0880 units per minute. The average waiting time in the queue decreased to 0.0581 unit per minute. The average number of customers waiting in queue also dropped from 6.7670 to 1.4535 units per minute. This shows that adding a second barista reduced congestion and helped customers move through the system more efficiently.
For this project, we also used Cloud to build a visual process model of the coffee shop queue. Both scenarios will run for an 8-hour workday, and we used 50 replications to get more reliable average results. And from the chart, we can see that in the one barista system, the average number of customer arrival was about 199.8 customers. The average queue size was 3.8 customers, and the average waiting time was 8.3 minutes. The average time in the system was about 10.8 minutes, which means customers spend around 10.8 minutes total from arrival to access. The barista utilization was 79.5%, so the single barista was busy most of the time. And in the two barista system, the average number of customer arrival was very similar, around 200 customers. So the comparison is fair, however, the performance improved a lot. The average queue size dropped from 318 to 0.16, and the average wait time dropped from 8.3 minutes to 0 minutes, and the average time in the system also decreased from 10.8 to 2.3 minutes. The main takeaway is that adding a second barista almost eliminates customer waitings and help customer move through the system much faster. However, there is also a trade-off. Barista utilization decreased from 79.5% to 41.6 to 62%, which means the two barista system provided better customer service, but it also creates more idle capacity. And now, let's focus on the queue behavior over time. This slide is important because it does not only show the average results, it also shows how the line changed during the simulation days. For the one barista system, the queue builds up more often because it's only one person serving customers. And based on the data, the average maximum wait time was 28.76 minutes. And in some runs, the maximum wait time reached as high as 78 minutes. And the average queue size was 3.8 customers, but the maximum queue behavior shows that the line could become much longer during the busy periods. And for the two barista system, the average maximum wait time dropped to 5 minutes, and even the highest maximum wait time across the replication was only 10 minutes. This means that with two baristas, the queue was usually close to zero with only small and short breaks. So these slides give a visual proof of the same conclusion from the previous slides. One barista can create constructions and long lines during the busy periods, while two baristas makes the system smoother and more stable. Overall, the cloud simulation shows that adding a second barista greatly reduces queue build-up, waiting times, and total time in the system.
The R simulation was the code based version of our model. It allowed us to build the simulation using programming logic, which made the model repeatable and easier to modify. In R, we simulated 100 customers. Inter-arrival times were randomly generated from 1 to 10 minutes, and service times were randomly generated from 1 to 6 minutes. The same arrival and service times were used in both the one teller and the two teller scenarios to keep the comparisons fair. The R results also showed improvement when moving from one barista to two baristas. Average waiting time decreased from 0.94 minutes to 0.06 minutes. Maximum waiting time decreased from 12 minutes to 2 minutes. Average system time also improved, decreasing from 4.58 minutes to 3.70 minutes. This means customers spent less time in the system when two baristas were available. When we compare Excel, Clouds, and R, the exact numbers are different because each simulation method used a different structure and scale. Excel used spreadsheet based queuing calculations. Cloud used a visual process simulation over a 480-minute workday with 50 replications. R used a code based simulation with 100 customers. Even though the numbers are not identical, all three simulations show the same overall trend. Adding a second barista reduced waiting time, reduced queue buildup, and improved customer flow. Excel helped make the calculations transparent. Cloud helped visualize the process and resource usage. R made the model reproducible and easy to adjust. Together, the three methods gave us a stronger understanding of the coffee shop queuing system. One important finding from the project is that there is a trade off between customer service and staffing efficiency. In the one barista system, resource utilization was higher, meaning the barista was being used more efficiently from a labor perspective. However, the downside was the customers experienced longer waits and larger queues. In the two barista system, customers waited less and moved through the system faster. And the downside was that utilization decreased, meaning there was more idle capacity. So the best staffing decision depends on the business goal. If the priority is controlling labor costs during slower periods, one barista may be enough. But if the priority is reducing wait times and improving customer satisfaction during busy periods, two baristas would be the better choice. In conclusion, all three simulations support the same main finding. Increasing service capacity improves queue performance. The Excel simulation showed that adding a second barista reduced average waiting time in queue and in reduced the average number of customers waiting. The cloud simulation showed that the two barista system nearly eliminated waiting time and greatly reduced queue size. The R simulation confirmed the same trend by showing lower average waiting time, lower maximum waiting time, and lower system time. Overall, the project shows that simulation modeling is a useful tool for evaluating service systems before making real operational changes. Based on our results, we recommend using one barista during slower periods when labor efficiency is more important, and using two baristas during busier periods when customer service and faster flow are the priority. Thank you all for watching our presentation today.